So in this tutorial, we're going to talk about mechanical properties of matter. Mechanical properties of matter. So basically, we're going to focus on solids, right? Okay, so without even wasting much of our time, so this topic basically focuses on an idea of deformation. Okay, deformation that is caused by a force when applied on a solid. Okay, so deformation, but actually a result of what? A force. So when you have an object, a solid, when you apply a force at different angles, you are going to deform the object. So deformation will actually differ to change in the properties of an object. It can be the change in size, it can be the change in length, it can be a change in what? In volume and etc. So that's basically what we're going to focus on as we talk about the mechanical properties of matter in solids. Okay. So we've got two types of deformation that we're going to talk about. Okay. The first one is where you have an object, right? You have an object that is elastic. You pull it this side, you extend it by a certain distance, let's say x, or you extend it by a certain length x. So after you let go, it gets back to its original position. So in this type of a case, we are saying after applying a certain force, it will retain its what? Initial properties. So in such type of a deformation, we are trying to call it is what? It's elastic. So what's elastic type of what? Deformation. The other case 2. So what is the first type of deformation? Case 2 is where you pull something, you apply a force on an object. Of course, I'm going to use the same example of extension. You pull it in the sides, then after letting go of it, it doesn't go back to its original position. It remains as you've left it. So what type of a deformation is called what? Plastic. Plastic type of what? Plastic type of deformation. Okay, so mechanical properties of matter focuses on the study of solids being deformed. Deformation can be either change in size, change in the shape, change in volume, and many more properties of a solid changing. Okay. So basically, we're going to talk about various types of concepts. Okay. We need to talk about the stress and the strain. All right. So what is stress? So stress is the force applied causing deformation divided by what? By the area. Okay. So it's like what quantity or what part of the force that you have applied is acting on a certain or the unit of area. Okay. So what is your stress? On the other hand, your strain is actually what? Is actually the change in length divided by the original what? The original length. So an example is when you have a 4 meters object, then after applying a force this side, you extend it to 6 meters. So the change in x is what? Is 2 divided by what? The original, which was 4. So basically you have 0.5 as what? As your strain. So stress being the division of force and area, the units are newtons per meter squared. On the other hand, for a strain is actually a ratio because you have meters over meters, so it has got no units. Right. So I've talked about the issue of stress and strain. So we need to know that a force causing deformation on objects can be applied in different or various ways. Okay. So the first one, I'm going to call it tensional force. Tensional force. So a tensional force will cause a what? An extension. So when you have an object, you are putting it in the sides, you are extending the length. That is actually a tensional force that is in action. Okay. So how do you calculate the stress in such a situation? So in such a situation, stress is given by the change in x divided by what? So that change in x is actually, sorry, okay, so stress is actually force applied divided by the area. So the area is going to be the side or the surface on which you are applying the force. So let's say if I'm applying it on that surface, I have to calculate the area. Okay, then I divide that into the applied force. Then on the other hand, for the strain, since we're extending it, it is going to be given by what? The extension divided by the original length. Okay, so I've already given you an example area. Okay, so away from the tensional force, the second type of a force that we can talk about that can lead to deformation is what? A compressional force. Compressional. So from the word compress, you're trying to reduce something. Compressional force. So this, instead of now putting it in the sides, you are now applying the force inwards, leading to a reduction in the length. Okay. So in such a case, the stress will still be given by the force that you apply divided on the surface area of the side where you're applying your force. And the strain, on the other hand, is going to be given by the negative change in the length divided by what? The original length. Why are we putting a negative there? We are putting a negative there because we know, for example, if we had 4, we reduce it to 2 after applying the compressional force. So the change is going to be 2 minus 4, which is going to give us negative 2, divided by the original 4, which will be negative 0.5. But we don't want that. So after we put a negative there, it becomes positive. All right. So these concepts are very easy for you. You need to understand them. The third one is the bulk kind of a thing. So for the bulk, what happens is you have a solid or an object, you're applying a force of a same magnitude from other directions or from other sides. All right? So this force is applied perpendicularly to what? To the body. So in such a case, the stress is going to be given by what? The applied force perpendicularly divided by the surface on which you're applying, the area. Then the strain in such a case is not going to involve the length, but instead it's going to involve what? The volume. So this is leading to a reduction in the volume of a solid. So therefore, our strain is going to be given by what? Our strain is actually going to be given by the negative change in volume, because the volume is going to be reducing, and therefore if you subtract the final volume minus the initial, it will give you a negative. So you need to multiply by the negative so that we maintain our strain to be positive. Okay, initial volume. All right. Finally, the last part of the force or a type of deformation that is going to result is a shear. Okay. So this is a case where now you have a solid there, you apply a force parallel to the object. So what is going to result is that these points A and B are going to be maintained, then it's going to slant on top. All right. So the height is going to be maintained. Okay. So what is still going to be the same? L, L. So we're going to call that this point has moved, so that it becomes slanted. So that is going to be called the change in x, and this is going to be called angle theta. So in such a case, how different is it? So in such a case, we calculate our stress still by the force that you've applied parallel. So our stress still remains force applied divided by the area on which you're applying what? That force. Then the strain becomes different. So the strain in this case is going to be given by that change or a displacement on the sides on top divided by the perpendicular heights L there. The strain can also be calculated to be equal to tan theta. That's another way of determining what? Determining the strain. Okay, so basically this is an introductory video to mechanical properties of matter. We've talked about the introduction, what deformation means, and the different types of situations that we may have. So in the next video, I'll talk about the elastic moduli and be able to calculate the Young modulus, the bulk modulus, and the shear modulus, and not forgetting the Poisson's ratio. And that will mark the end of this topic. So thank you very much for watching. Make sure to like and subscribe for more videos.